Hi, this is Will at machineloveus.com. Back here with another data visualization video. This week we're going to be looking at the Data is Beautiful subreddit data visualization battle. This time it's the data visualization of the month that we are going to be participating in. And eventually we will construct this infographic right here. I have a series of 3 of them that I'll be uploading for the competition. So let's get down to it. This data visualization battle provides us with data. The data being provided is from the show The Office, and it's every line of every season. You can download it from this link here. Get it into a CSV and bring it into where you keep your IPython notebooks, and we will go through it now. Okay, so once you have the data somewhere where you can grab it, let's bring in the modules that we'll use for this task. That's pandas and the CSV module. Okay, then we are just going to read in the CSV with pandas, just like we always do. This time there's a little twist that we are going to be using an encoding that's Latin 1 for our data frame. And what that'll allow us to do is to make sure that our apostrophes don't get converted to ASCII. And so it'll bring in all of those apostrophe words don't, won't, shouldn't correctly. Let's cut down the data frame next into just the variables that we want to use. We don't need all of these extra variables. I don't like to see them around. So as you can see, we get an ID, which is just a line number, season, episode, scene, the line text, the speaker, and whether it was deleted from the episode. We don't need all of those things, so let's just take a look at this pared down piece. So I didn't describe what this visualization eventually would be. So what I wanted to do with this data is to show the conversations at the office, meaning I want to get a sense of when Michael speaks to Jim, what does that look like? What is the tone? What are the words that they're using? Conversely, when Jim speaks to Michael, his boss, presumably he's using a different set of words. He's a different person, and that's his boss he's talking to. So the words he'll use are different. So for grouping the seasons in 3s, I just wanted to go through and take a look at the conversations and how they evolve over the seasons. And you can see from the final product that they are quite different. So that's the goal of this analysis, is to look at the conversations between members in the office over the period of the show, and then visualize that. And I visualize it for Dwight and Michael, and for Pam and Jim, and for Michael and Jim. And you can see all of those at machineloveus.com, or I will post them to the Reddit, so you can see them there, and hopefully we'll win a little bit of Reddit internet points. So here's the hard part now. This is where we actually have to say this is the hard part, where we actually have to attribute conversations. So Michael starts off, he says, all right, Jim, your quarterlies look very good. So Michael's talking to Jim, Jim talks back to Michael, Michael talks back to Jim. And then if you take this out a bit, you could see that Michael and Jim go back and forth for a little while, and then Michael does that thing that they do in the office so often, which is just talks directly to the phone, talks to himself. So we don't want this as part of the conversation between Michael and Jim. What we want to know is we want to capture these lines as the conversation between Michael and Jim, and that's the kind of pattern that we want to follow. And so to do that, we need to find who is the current speaker, Michael, who is the next speaker, Jim, and then later on in the conversation we want to know who is the previous speaker. So current speaker, next speaker, former speaker, so we can attribute more of these conversations to people. So to do that, I am going to use iterators and iterate over this data frame, looking for the last speaker, the next speaker, etc. And I will speed this up for you a little bit, but I think you'll see where I'm going. Okay, so I am iterating over the rows of the data frame, and then I am looking back, or from the perspective of the current row, I'm looking back at the last row, and I am figuring out who is the current speaker, who is the next speaker, and whether, according to my rules that I laid down before, whether they are whether this is a valid conversation or not. So the current speaker, we're ahead a row, so the last speaker is the current speaker because I'm setting the values on the last index. This is kind of confusing, but just bear with me that we are looking in the future, and from the future's perspective, the previous row is where we're setting the data on. So the next speaker is the current row. The current speaker was the last row, and for this to be valid, we need to make sure that the current speaker and the next speaker aren't the same person. So Michael isn't talking to himself, and the last speaker isn't the current speaker, so Michael wasn't talking to himself. And then we need to keep that index iterating. We actually have two iterators working together, and we're going to set the last speaker as the current speaker. So when this all shakes out, you can see that what we'll have is a data set where we have the current speaker, last speaker, next speaker. Okay, so we just started off from the very beginning, so there was no last speaker, so this empty value is correct. Let's go out a couple more rows so we can see that the current speaker is Michael, the next speaker is Jim, and this is a valid conversation between Michael speaking to Jim. Let's go down. So here, Michael has been talking to himself a few times. He's doing one of those awkward conversation moments into the camera. And then Pam, he mentioned something and Pam says, well, I don't know. So this is Pam to Michael, and that is a valid statement, and Michael is the next speaker. And then Pam and Michael have a back and forth. So this looks good, and all of these are valid. So where Michael says, okay, let me show you how it's done. He's not, the last speaker was Jim, but the next speaker is Michael. So he's not necessarily talking to Michael, or he's not necessarily talking to Jim. So this is another part of the analysis where it can fall down a little bit, and maybe you want to make some tweaks to fix this up. But these first few lines, 1 to 4, 0 to 3, are Michael and Jim's conversations. Okay, so we only want to keep the portions of our data frame where this valid flag is true. So this is going to cut our data frame down a significant amount, and then we only really need to keep just the essential variables. I just like to do a bit of cleanup myself. Last speaker, current speaker, next next speaker. Okay, let's take a look. I think the original data set had 50,000 lines. It looks like it still has a significant number of lines, 55,000. I'm not actually sure how many lines the original had. We can go back and check that. Let's go back and check that. Luckily, we can just rerun this all pretty quickly. So 59909, and now after running it, we lost about 4,000 lines. So because I ran this again, I need to rerun all of these cells again. That's not very hard to do. So let's keep moving forward. We'll take a look at that when that comes back. Okay, and now what we can do is split these into separate data frames. So we can say Michael's conversation to Jim. This is Michael speaking to Jim. Would be something like where the current speaker is Michael, and the next speaker would be Jim. Right, so in this data frame, what we'll have is every time that Michael is speaking directly to Jim. And we can make several different data frames. We could go Jim to Michael, which is what you'll need to do to recreate the visual that I showed you before. But let's just start with this. You can find more of this. You can find this notebook on GitHub. I'll provide the link to the Machine Lovelace repo. And you can see the visuals on the site or on Reddit. But now what we need to do is clean this data because there are words that get in the way. There are stop words that we want to remove. We might want to tokenize our data set. Tokenization being just getting down to the root words. Actually, tokenization being splitting out our sentences into their individual tokens of meaning. It's the stemmer that breaks apart words like great into good, good being the stem of great. We will experiment with that. Let's initialize our stemmer, our tokenizer. The regex tokenizer is great because we need to remove punctuation. So this will help us do that. We need to remove stop words, which are the ands and the sort of lubricant words between sentences, keeping meaning together. Okay, so let's see. Regex tokenizer. Regex P. No. Stop words dot words. Okay, great. Okay, so now I just set up this dict of lists. I set up this dictive list to capture the words as I iterate. Each one of these numbers represents a season. I also want to remove the names of people that are being spoken to. I'll just keep Michael and Jim since I'm just doing that for now. And then I will iterate again over this data frame and actually put together the words to make to be able to eventually get the word cloud. Okay, so I bring my text down to lowercase, which I just think of as a best practice. I split this into tokens. For each token, I take the words that are not stop words, and then for all of that text, if it's not in this additional dictionary of names, then I put it in my dictionary here. And I have Michael to Jim. Okay, so then I could do something like this. And now I have all of the words that I can use to make a word cloud. Okay, great. Okay, so let's just do the basic word cloud here. I have another article on the blog that makes word clouds out of Reddit comment threads. You can check out. So I have a dictionary of lists. I don't have actual text here. That was just a variable that I used in that previous function. Let's just do the first 3 seasons here. We need to create one long string for this Python library. And then there you go. So that is essentially the word clouds that I string together and use Google Draw Toolkit to make this final visualization. Again, if you'd like to see that final visualization and how I clean it up and eventually how I clean this notebook up, please visit machineloveus.com or see it on GitHub, and please like and subscribe to the channel. Thanks.